let's try classifying some polynomials. Okay, we've already done some of these, but more practice. Practice, practice. So for each polynomial, first simplify if possible, then give the degree and tell whether the simplified polynomial is a monomial, binomial, trinomial, or none of these. Okay, so for each polynomial, first simplify. Simplify means basically is if you can combine these terms, you need to combine the terms because that will change the degree sometimes. Okay, and then you're going to get different results, whether it's a monomial, binomial, or trinomial, depending upon how many of these terms we can combine. So in the first one, we have a third degree and a 0 degree. So these are different terms, so we can't combine these. Like terms have the same variable to the same power. So the only way these would be like terms would be that they would both be x cubed or they would both be constants. Since they are not like terms, meaning they do not have the same variable to the same power, we may not add or subtract these two terms, they stay separate. If they were like terms, we would add or subtract, in this case add, their coefficients. Okay, so again, this doesn't go anywhere. So and it's already in descending power, so shouldn't be an issue. Okay, now they do ask for the degree, and then they do want to know whether it's monomial, binomial, or trinomial. Okay, now this is simplified, so I guess I could put simplified. Sorry about my handwriting. Okay, and the next one is the degree. Well, the leading coefficient, this is already in descending order, so the degree is 3. And then what we want is whether it's a monomial, binomial, or trinomial. In this case, we would say it is a binomial. There we go. Okay, let's try the next one. Now, in this case, we have an x, and an x. Because all these are like terms, because they all have x variables, all of which have the first degree, they are like terms. Given that they are like terms, we are going to be able to add or subtract their coefficients. So we would say 6 minus 8 is negative 2. Negative 2 plus 13 is positive 11. And then we're just going to reattach the x. So we know that this turns out to be 11x. Now, that's understood to be the first power. So we would say the degree is 1. We are going to say that it is simplified now. And we were going to say that it is a monomial because it only has one term. Monomial. Okay, excellent. All right, let's try some more. Okay, let's say we have xy, xy, xy. So we have the first one, the second one, and the third one. All right, so 4x minus 5y plus 2x. Now, so xy, they're both x and y multiplied together, and they're both to the first power. And so are the next one, and so are the next ones, right? So these are all like terms, meaning I can either add or subtract their coefficients. So we would say 4 minus 5, which is negative 1, negative 1 plus 2, which is positive 1. So we would just say x, y, right? And you can put the 1 there, but it's unnecessary. Just like it's unnecessary to put 1 there and there. It's just implied or understood. Excuse me. So now it is simplified. Now that it is simplified, I can say the degree is 1. And I can also say that this is a monomial because I ended up with one term, monomial. I'm just too lazy to write the rest. Okay, so we have 2x, 3x, 8x, and a constant. Okay, so this constant is not a like term to the other ones. So these first three are like terms, the last one is not. So the first one has x to the first power, the second one has x to the first power, the third one has x to the first power. Like terms, we can add or subtract them. Okay, so we say 2 minus 3, which is negative 1. Negative 1 plus 8, which is positive 7, gives me 7x. And then I just bring down the minus 12. I cannot combine these, though, right? Because this has an x and the constant on that one. Those are not like terms. So since they are not like terms, you have to keep them separate. Okay, now, so we have finally simplified this. So now I can identify the degree, which is just the degree of the largest degree of all the terms. And now we're going to say that this is a binomial because we have two terms right here. And that's it.